Okay, we're going to talk about crude oil and fractional distillation. Now, from crude oil, we are able to get our fossil fuels. Now, in an exam, they might ask you list three fossil fuels. So you would say coal, gas, and oil. Crude oil is formed from dead animals and plants trapped in the earth millions of years ago. So they're decomposed by bacteria via anaerobic respiration, and they form crude oil because of all the temperature and pressure deep within the Earth's surface. Key to note here is dead plants form coal and dead animals form crude oil. Crude oil is found in the Earth's crust. It can be pumped to the surface. It is transported to refineries through pipelines or in oil tankers. The problem with crude oil is that sometimes there might be an accident, such as an oil spill, and that can cause a lot of harm to wildlife and damage beaches. You may have seen the BP oil spillage a few years ago. Oil can affect lots of wildlife, including birds. The birds' feathers get stuck together and the birds may die. Detergents are used to break up oil slicks, but these chemicals are toxic and can harm or kill wildlife. Here's an example that we were talking about in the last slide about the oil sticking to the bird's feathers. These birds are unfortunately dead. One of the problems when they drill for oil is that there might be an oil spillage. Okay. Fractional distillation. This is the process of separating crude oil. Firstly, crude oil is a mixture of many hydrocarbons. You should note that a hydrocarbon is a molecule that contains only hydrogen and carbon atoms. See, in that definition, a hydrocarbon is a molecule that contains only. You have to put the word only in your answer. If you don't, you will get 1 mark out of 2. It's just one of those things. So, hydrocarbon, hydrogen, and carbon only. Different hydrocarbons have different boiling points. This means that crude oil can be separated into useful fractions that contain mixtures of hydrocarbons with similar boiling points. This process is called fractional distillation. Here's an animation of fractional distillation. I'll show you how it works. Now, the first thing you should note at the bottom of the tower, that's the hottest. So if it's the hottest, it means any fractions that come out at the bottom have the highest boiling points. Now we'll have a look at some of the fractions that are generated from separating crude oil. One, liquid petroleum gas, petrol, naphtha, paraffin, diesel, fuel oil, lubricating oil, and bitumen. Boiling points should be highest at the bottom and lowest at the top. That is because at the bottom the chain length is a lot longer compared to the top. So the longer the chain, the higher the boiling point. So the hydrocarbons that make up crude oil vary in size. So we said that here because you can see at the bottom bitumen is 120 carbon atoms in length, whereas at the top, for example, petroleum gas is only 3. So they do vary in size, so they have a different chain length. The chain length refers to the number of carbon atoms in the molecule. So we said already, the larger the hydrocarbon, the higher its boiling point. Some key things you should think about for your exam when you're talking about fractional distillation. First thing is you heat crude oil so it turns into a gas or a vapor. Now, if a gas is turned to a liquid, that is called condensation. If a liquid is changed to a gas, if a liquid is changed to a gas, that is called boiling. If a liquid is changed to a gas, that is boiling. So you need to say about they're boiled to a gas or vapor. They then condense at different temperatures. and then they're collected. So they cool to condense. Hydrocarbons condense at different temperatures. They condense at different temperatures because they all have different chain lengths. The larger chain lengths, such as bitumen, will condense at the bottom of the column. So a bit of a quiz for you. Which forces are responsible for boiling points? Now the answer for that is intermolecular. So these are forces between molecules. The larger the chain, the more intermolecular forces there are. If the forces are strong, the boiling point is high. So which are more useful, small chain fractions or large chain fractions, and why? The most useful fractions, i.e. they will have a high demand, are the small chain fractions. And a way that we can ensure that we get lots of small chain fractions is a process called cracking, which we'll look at in a future series. So which is in higher demand, long chain or small chain? Definitely small chain. Okay, so moving on. Fractional distillation. That's why the animation didn't work, but this one works. A fraction is a set of hydrocarbon molecules of similar size and similar boiling points. So fractions are when crude oil is vaporized and these fractions boil off at different temperatures. So bitumen would be one fraction, petroleum gas is another fraction, naphtha is another fraction. This is about the supply and demand for the crude oil. So in the yellow you can see the amount we obtain from crude oil, so that's the supply, and in the blue is the demand for these. So you will see, if you look at petrol in the graph, second from the right, you can see that there's a high demand for petrol, but we don't have a lot of it. Therefore we need to try and fix that problem. So let's have a look at that question. Question, for which fractions is demand greater than supply? So all you're going to look at for that graph is if the yellow bar is higher than the blue bar. Sorry, the other way around. So you're going to look at which fraction is demand greater than supply. So you're looking for the blue bar to be higher than the yellow bar. So refinery, petrol, diesel oil, they all have greater demand than they do have supply. Second question, in order to increase the relative amounts of these fractions, longer chain hydrocarbons are broken down into shorter chain hydrocarbons by a process called cracking. Okay, so cracking is when you break down a long chain hydrocarbon into an alkane and an alkene. So it's possible for you to break down long chain hydrocarbons into petrol, and petrol as you can see from the graph, there's a big demand for petrol. So cracking helps us meet the demand of the consumers. Catalytic cracking. So the word catalytic comes from the word catalyst. Now, a catalyst is a substance that speeds up the rate of a chemical reaction, but doesn't get used up in the process. Now, as you can see, catalytic cracking. Cracking is the heating of long chain hydrocarbon molecules at high temperatures over a catalyst, splitting it into smaller, more useful molecules like petrol. The small molecules produced are then separated by distillation. So big molecules go in, they have a high temperature and a catalyst. Molecules break up into smaller molecules. That's cracking. So large hydrocarbon molecules can be broken down into smaller molecules using a catalyst. This is called catalytic cracking as an example of a thermal decomposition reaction. Thermal decomposition, so thermal just means heat, decomposition means breaking down. The hydrocarbon molecules are heated until they are turned into vapor and then mixed with a catalyst. The molecules break apart, forming smaller alkanes and alkenes. Now, in an exam, it might ask you what does a large hydrocarbon break down into. Always breaks down into an alkane and an alkene. Usually, one of them is used as a fuel, for example petrol, and the other is used to make plastics. Alkenes are reactive molecules that are used to make plastics and other chemicals. That's just what I said. Catalytic cracking. Here's an example of one. So at the top you have octane. Now if you think of an octagon has 8 sides. So octane has 8 carbon atoms. It's not that useful. So what they want to do is crack it into smaller molecules. They use heat first, so heat and pressure to vaporize it. Then they add that to a catalyst, and it breaks down into hexane, which is the alkane, and ethene, which is the alkene. You can see that hexane is used as fuel, and ethene is used to make plastics. So, for example, if you have ethene and you join lots of ethene molecules together, you'll make polyethene. The symbol equation is at the bottom here. C8H18 breaks down into C6H14 plus C2H4. Now if you look at the right hand side, you've got C6 and C2. So C6 plus C2 equals C8. This is on the left hand side of the equation. H14 and H4, add them together, you get H18, which is on the left hand side of the equation. So it's perfectly balanced. Note that you always get an alkane and an alkene. This is a research task that at the end of this, if you want to go and do some research, do some homework, try and get your grade up. These are a list of questions that we've run through. So I'll leave this for you. I'll go through them quickly. Name 3 fossil fuels. You can find the information in this video that we just done. Why are fossil fuels non-renewable? So I'll tell you that renewable sources are never going to run out. So what does the word non-renewable mean? I could just give you the question for the answer for number 3. I'll go on to number 4. How was crude oil formed? Remember, you want to talk about dead plants, animals, temperature, pressure, bacteria, decomposition, some of the keywords you want to put in your answer. Where are oil reserves found and how is oil extracted? You can find the information at the start of this presentation. Name the 3 biggest crude oil producing countries in the world. So that's for your research. What are the uses of fossil fuels? So coal, oil, natural gas. Crude oil is separated by fractional distillation. What is fractional distillation? So you want to say crude oil is heated into a vapor. It is then condensed into liquids and the fractions are collected according to chain length and boiling points. Research view, give use of refinery gas and petrol. And what environmental damage can be caused by the extraction, transport and use of oil? Remember the birds and the oil sticking to the feathers. That'll give you the clue for that one. Okay, so that concludes our first lecture. I hope it was beneficial to you, and we'll be back soon. Thank you.